Hi everybody, this is Mr. Karlovsky, and today we're going to talk about the law of sines. It's going to be one of our tools in our tool belt as we do applications of trigonometry. Today we're going to walk you through the proof of where the law of sines comes from and a quick example and get us prepared for class. So the big thing about the law of sines as we begin is that it works for any general triangle. And what I mean by that is that it doesn't have to be a right triangle like we had for a SOHCAHTOA or a right triangle trigonometry application. So I'm going to try and draw a squiggly generic triangle. And let's say we use our typical capital letters for our three vertices. Now, one thing in trigonometry applications is it's very helpful as we study it to label the sides across from an angle or a vertex with the lowercase letters. So little a and little c and little b. So that's my generic diagram of a general triangle. Even if it looks isosceles or looks acute, if there's no numbers given, don't assume anything. Those letters can stand for any values that are possible. So where the law of sines comes from is if we just think about how in this triangle, of course, there's three sides and three angles, but as when we studied the area of a triangle a long time ago, we had to know the height or the altitude. So I'm going to draw in the height from angle C down to side C, a little bit off there, but drawing that height, and I'm going to label it H. And so that would be the height of that triangle from side C to angle C. And so now we realize, oh, well, since a altitude has to be perpendicular to the side that it's going to, we've actually split this generic triangle into two right triangles. Now that we have a right triangle, we can put our brain into SOHCAHTOA mode. And I'll start on the left, that from this angle A, and thinking of this H that I just wrote in and its side B, we have a relationship that maybe not surprisingly uses sine. So we would have that the sine of angle A equals its opposite, which in this case is H, over its hypotenuse, which is side B. And what I'm going to go ahead and do is solve that equation for H. If you can imagine multiplying both sides by B, we would have that the length of H would be B times the sine of angle A. So now I'm going to hop over to the right triangle and look at angle B. And its opposite, H, and its hypotenuse A, and go through this quickly, we would have that the sine of angle B would equal its opposite H over its hypotenuse A. And similarly, solving for H, we get H equals A times the sine of angle B. And now we go, hey, well, since the H over here equals the H over there, they're the exact same H, we would have the connection that those two expressions, B sine A, must exactly equal A sine B. And although there's nothing wrong with that formula, what we usually do is divide both sides by little a times little b, and we get the start of the law of sines, and we get the sine of angle A over little a equals the sine of angle B over little b. And now I'm going to ask you just to kind of jump ahead that since A, B, and C were completely arbitrary, we could have picked any height. I didn't have to do the height from angle C. I could have done the height from angle B. If you don't mind me skipping the step, we actually get the third relationship of the ABCs also is true, and this is the law of sines. Be sure to put that into your notes. That is our tool that will go into our tool belt, and we will use it when we can. Okay, so that's the law of sines. So now I'm going to show you how to use it. So here we have an example where we are going to solve the triangle, which means find all missing sides and angles. Here I have a generic triangle, and I say generic because we don't know any other information to make it, as a more special label of isosceles, equilateral, etc. So we have two angles given, 77 degrees and 41 degrees, and one side length of 18 inches. And so we're going to solve the triangle. Now, first thing that's pretty clear to find would be angle K. Hey, I have two angles of a triangle. So therefore, angle K, let's get that out of the way. 180 minus 77 and 41. And so angle K is 62 degrees. So look at that, get 1 right away. Angle K is 62 degrees. So now we're going to talk about how the law of sines is all about that opposite pair. So I look at the opposite pairings of 41 degrees is paired with side F, which I don't know. 77 degrees is paired with side J, which I don't know. And then 62 degrees is paired with the 18 inches I was given, and that's good. You need to have one complete pair in order to do a law of sines problem. Now, it doesn't matter whether we solve for F or J first. I'm going to solve for F. And so using law of sines with those ratios being equal, I would set up that the sine of 41 degrees over side length F is equal to the sine of 62 degrees over side the 18 inches. And so therefore I have my one unknown, and I'm going to quickly cross multiply and solve here. And F sine 62 equals 18 sine of 41 degrees, and divide both sides by sine of 62 degrees, and then go to the calculator. And as I go to my calculator here, I'm going to do 18 sine. Make sure you're in degree mode as you do this. I got burned by that the first time here. 18 sine of 41 degree mode over sine of 62, and simple calculation, and we get that the length of side F, I'm going to go to 3 decimal places, is 13.375. So F is 13.375 inches. So that's F we now know. And now I'm going to go and just find the other one I didn't know, which is side J, and set up again. I'm going to do the sine of 77 degrees over J equals, and I'm always going to go back to that pair I originally knew, sine of 62 degrees over 18. And I'm going to cross multiply and solve this quickly here, very quickly. And boom, look at that, I'm already done. And I got J is 19.864 inches. And so we're done with the problem. We have solved the triangle. We found the one missing angle we didn't know and the two missing sides that we didn't know. Now, there's really not much for you to do now to check the reasonableness of your answers except for one check. And that is what I would call the small, medium, large relationship, that the smallest angle is always opposite the smallest side or shortest side. So as long as we double check as best we can that 41 degrees is the smallest angle and side F of 13.375 is the shortest side, the medium of 62 is opposite 18, which is the medium of the three sides, and 77 is the largest angle across from the 19, which is the longest of the three sides. That's pretty much all we can do to check the reasonableness of our answer, and hopefully we got it right and our calculator was in the right mode and all the other mistakes that are possible. So there you go, kids. That's the law of sines. Remember, it is used on any triangle to find sides and angles that are missing. And we'll do some more practice in class and keep on going. All right, I will see you in class.